All right, now I'm going over the algebra portion of the review. Questions 11 through 13 say solve for x. So the first thing we have to do is we have to identify the angle relationship. So I'm going to start by making a point in the middle, and I'm going to draw a circle around this. And I'm going to highlight in the 8x plus 26 angle and the 3x angle. And what I notice is that together, these form this half circle. And that makes them a linear pair, or maybe you'll call this supplementary. And what I know about a linear pair is angle 1 plus angle 2 equals 180. So what I can do is I can call one of these angles angle 1 and the other one angle 2. And I can plug those in for angle 1 and angle 2 of my diagram. I can combine my like terms. Well, 8 plus 3, so that's going to be 11x plus 26. I can subtract 26 from both sides. And I can divide by 11. And the problem just says solve for x. It's not asking you for a particular angle, so I am done when I get the 14. For number 12, what I'm noticing is I've got this box in the corner, and to me that means that these are complementary angles. And complementary angles are angles that add together to form a 90-degree angle. So I can give one of these my angle 1 measure and the other one my angle 2. So I know that together, when I add those two angles together, I'm going to get 90 degrees. And if I combine these like terms, it's like 3 plus 1, so it's 4x equals 90. And if I divide both sides by 4, I get x equals 22.5. In this picture here, if I drew my circle and I shaded in what I have, I don't quite tell that these are half the pizza. What I know is that these slices are opposite from each other, and these are called vertical angles. And what I know about vertical angles is that they're equal. So I could call this angle 1 and this angle 2, and basically what I'm doing is setting one equation equal to the other. I'm going to get the x's together by subtracting 8x and dividing by 4 to get x equals 5. The next few problems don't say just solve for x. They're actually asking us to find a specific angle. So here's what I need to know first, is that the three angles inside of a triangle add up to 180. So I can give each of these their own name, and I can take the angles, add their equations together, and this top is just a 90-degree box, and set that equal to 180. So from here, I'm just combining my like terms. 2x and 5x is 7x, and 1 plus 5 plus 90 is 96. I can subtract 96 from both sides, and I can divide by 7 to get x is 12. The question asks for BAC, so think about taking B, going to A, and going to C. The angle that we're really tracing is angle A. And the equation for that is 2x plus 1. So I'm just plugging 12 into that, and I get 24 plus 1, which is 25 degrees. I'm going to use that same type of concept in the next one, but I don't have the three angles inside of a triangle because the inside is the 65 and the x. I need to know that third angle to be able to do this. So what I'm looking for is to find this angle right here. And what I know is that together, this outside angle and this inside angle form that half circle relationship, right, which is called a linear pair. So I can find this angle right here by doing 180 minus 105. So now I have the inside angle is 75. Now I know that for a triangle, I can add the inside angles together and they should equal 180. So I'm going to combine the like terms, 65 and 75. I'm going to subtract the 140 from both sides to get x is 40. Now the question says find TUS. So I'm going to start at T, head towards U, and go to S. And the angle that I'm tracing over is x. So really I'm just looking to find x, which I did. It's 40 degrees. All right, this picture looks like it could be complicated, but really it's just two triangles. So I've got a triangle over here, and I know that the three angles inside of a triangle have to add up to 180. So I'm going to combine my like terms, 72 and 86. So I've got 158 plus angle 3 has to equal 180. So angle 3 must be 22. Looks like that's the first thing I'm finding. Well, the relationship between angle 3 and angle 4 is that they are vertical to each other. And vertical angles, because they're opposite of each other, and look, they look about the same. They're real skinny angles. Vertical angles are equal. So if angle 3 is 22, so is angle 4. And then I just have another triangle over here. But if I know angle 4 is 22, and I have a 70-degree angle, I can solve for angle 5 by adding those together and setting them equal to 180. So I've got 92 plus angle 5 equals 180. And I could subtract 92 from 180 to get that angle 5 is 88 degrees. All right, my last one from this section says, if BD bisects ABC, then, okay, so the word bisects means cut in half. So think about like if you have a sandwich and you cut it in half, what's true about both sides of the sandwiches? Well, if you're truly cutting it in half, you have two equal parts. So that's what's happening here. This line is coming through, this line is coming through, and it's creating two equal parts, which means this should be equal to this. So if I call this angle 1 and this angle 2, angle 1 should be equal to angle 2. So I'm just going to take my two equations and set them equal to each other. I'm going to subtract my 9x. Subtract my 27. Divide by 9. X equals 1. Then it says find angle ABD. So if I go from A to B to D, the equation for this is 18 times 1 plus 27. And that's 45 degrees. And DBC is 9 times X plus 36. And that's also 45 degrees.